This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts. In today's episode, you will learn how to make an IoT-based in-out time tracking system using the Nodemcu ESP8266 Wi-Fi module, the PN532 NFC RFID module, an I2C supported SSD1306 OLED display module, and Google Spreadsheet. The reason I selected PN532 RFID module is that it's a low cost and low power RFID module, and it supports multiple interfaces HSU, high-speed UART, I2C and SPI. In my previous video, I have already explained how to use all these three interfaces. In this video, I'm going to use the I2C interface because my OLED display module is also an I2C supported device. So using the I2C interface, I can reduce the wiring. So using only 2 pins on the Nodemcu ESP8266 Wi-Fi module, I can communicate with both the modules. As usual, I'm using the same ESP8266 development board. It doesn't matter if you don't have this development board, you can do all the connections on a breadboard. Anyway, let me show you all the connections. The SDA and SCL pins of the PN532 RFID module are connected with the Nodemcu ESP8266 Wi-Fi module D1 and D2 pins. D1 is the SCL and D2 is the SDA. Likewise, the SDA and SCL pins of the SSD1306 OLED display module are connected with the same pins D1 and D2 on the Nodemcu module. So using these 2 pins, we can communicate with both the modules, and this is only possible because of the I2C addresses. These modules have different I2C addresses. The VCC and ground pins of the OLED display module and the RFID module are connected with 3.3 volt and ground pins of the Nodemcu module. If you face any difficulty in doing all these connections, then you can follow this circuit diagram. You can download it from our website electronicclinic.com. I will provide a link in the description. One more thing that I would like to talk about is, as I said earlier, the PN532 supports multiple interfaces which are UART, I2C and SPI. For selecting any of these interfaces, you will need to accordingly adjust the toggle switches. Since I'm using I2C interface, so that's why channel 1 is on and channel 2 is off. As usual, before I'm going to explain how to set up your Google Spreadsheet and how to connect it with the Nodemcu ESP8266 Wi-Fi module, first let's watch this project in action. Right now, my Nodemcu ESP8266 Wi-Fi module and laptop are connected to the Wi-Fi. Let me also tell you, it's not necessary to use the same Wi-Fi network. You can use different Wi-Fi networks. It's an IoT project. You can monitor the employees or students in-out time from any part of the world. Anyway, on the Google Spreadsheet, I can monitor the date, time, name of the employee or a student, the ID, and the in-out status. I'm going to swipe the RFID tags and you will practically see how it works. The OLED display module is optional. If you remove this, it won't have any effect on the project. But it's good to use a display because without the display, you will be confused and you won't be sure if the card is successfully swiped. Right now on the OLED display module, you can see the message waiting. This means you can swipe the RFID tag. When it reads the RFID tag, the message success is printed on the OLED display module. I'm sure by now you might have got an idea of how does this system work. So without any further delay, let's get started. The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate and they will instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you are able to comment, markup, cross-probe, inspect and more. Comments are attached directly to the project, making them viewable within Altium Designer as well as through the browser interface. Design, share and manufacture all in the same space with nothing extra to install or configure. Connect to the platform directly from Altium Designer without changing how you already design electronics. Altium 365 requires no additional licenses and comes included with your subscription plan. Get real-time component insights as you design with Octopart built into Altium 365. Octopart is the fastest search engine for electronic parts and gives you the most up-to-date part data like specs, data sheets, CAD models, and how much the part costs at different amounts, etc. right in the design environment, so you can focus on your designs. Links to the Altium Designer, Altium 365 and Octopart are given in the description. You will need to carefully set up your Google Spreadsheet or Google Sheet for logging the required data. If you miss anything, you won't be able to get it connected to your Nodemcu ESP8266 WiFi module. I'm not using Google Spreadsheet for the first time. I have used it in so many other projects too. So for more information on Google Spreadsheet, watch my previous videos. I'll provide links in the description. For now, you can follow the same exact steps. You can download this Google script from the article. After updating the deployment, copy the deployment ID and paste it in the code next to the G-scripted ID. You can download this code from the article. I have added a link in the description. Finally, you can click on the upload button. For the Nodemcu ESP8266 Wi-Fi board and libraries installation, you can watch my getting started videos on the Google Spreadsheet, PN532 RFID module and SSD1306 OLED display module, or you can directly download these libraries from the article. Anyway, you can see the code has been successfully uploaded. After uploading the code, next I opened the serial monitor and started to swipe the RFID tags in order to find the tag IDs. Right now I'm using only 2 RFID tags. Anyway, I added both the tag IDs in the programming and again uploaded the code. I came back to Google Spreadsheet in order to check if I can receive the date, time, name, ID and status. As soon as I swipe the RFID tag, I receive the data. So this is how easily you can send anything from the Nodemcu ESP8266 to Google Spreadsheet from any part of the world. So that's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in the next episode and thanks for watching.